All right, so we were talking about how sometimes when you are doing a hypothesis test and you reject or fail to reject your null hypothesis, that you may have actually did the wrong thing. So these are what you consider your type 1 or type 2 errors. So there's always a chance that our conclusion from a hypothesis test is wrong. Maybe we did everything right, but our conclusion is wrong just because something didn't work out the way we wanted to. So we have two types of errors. The type 1 error is usually when your null hypothesis is actually true, and then we reject it. So we say it's not true. This is considered your type 1 error. So this would be, cereal does have an average of 20 ounces per box, but we reject that claim and say, no, it is actually less than. That would be your type 1 error. And usually this occurs because we just take bad samples. It could be because of bad sampling methods, or we just had bad luck and we didn't collect a very good sample. Or with like the lead testing or the lead exposure, the null hypothesis claimed that lead exposure does not decrease IQ. And we could reject that because we might collect just a really bad sample and we just collect too many people with a lower IQ. Like I said, just could be bad sampling. Your other kind of error is that your null hypothesis is false, but we do not reject it. And this is what we considered a type 2 error. So going back to that lead exposure, this would be the case of maybe the lead exposure does cause a decrease in IQ, but our test tells us that we are going to reject the null hypothesis, or not reject the null hypothesis. Therefore, we don't have evidence to support the alternative hypothesis. So in that case, even though lead exposure is showing a decrease in IQ, we would say, no, it is not. And that would be your type 2 error. And usually those are caused by the differences that we're trying to look for are too small to capture. So in this case, it may be that lead exposure is causing a decrease in IQ. It's just that decrease is so small that it's not noticeable. Or there's the other thing that can happen, which is maybe the lead exposure is combined with something else, or possibly, or it's a level of lead exposure that we're not really recording very well. And what we're seeing is that maybe some people, it's really causing a decrease in their IQ, and some people it's not. So once again, when you look at broadly across the board, you might miss that small difference because maybe it's a few people are having really, really bad reaction or just don't respond well to lead, I guess, and are more likely to have lower IQs. So it could be a small subgroup also is more affected than the entire population. But like I said, really this is that in the long run, broad scale, law of large numbers, that the differences are so small that we just don't notice them. So just remember, if we reject the null hypothesis, but the null hypothesis was in fact true, that's a type 1 error. If the null hypothesis, if we fail to reject it, but it was in fact false, that is a type 2 error. So in general, type 1 errors are more serious than type 2 errors. This is because type 2 errors result in false conclusions. So for example, like we said, the null hypothesis that things are true. So, maybe we're looking and we're saying like, oh, your cholesterol levels are this. And then we do a test and we, so that our null hypothesis would be true, but we do a test and it's telling that your cholesterol levels are way lower than they are. Then we would tell you, oh, your cholesterol's fine. And we wouldn't do anything to treat it. So that'd be your type 1 error. Type 2 error, that's like I said, where the conclusion is false. So maybe the null hypothesis is that your cholesterol is high, but we are, like I said, the hypothesis your cholesterol is too high, but it isn't. And then we reject that claim and say it is too high. Worst case scenarios, you might get some medication, it'll test you again, and you'll be like, oh, okay, maybe we were wrong. It's probably not going to have a dire result. Type 1 errors are likely to cause us to ignore something like a cancer diagnosis. So it's more likely that there will be cancer and we will say there's not. which is makes it more serious. Where a type 2 error is where we might say you have cancer when you don't. So that's a little bit of the difference here. Ideally, we would like to minimize the probability of both kinds of errors. Unfortunately, with a fixed sample, decreasing the probability of like a type 1 error would increase the probability of your type 2 error. Or if I decrease the probability of the type 2 error, it increases the probability of the type 1 error. So we're kind of like stuck that we can't optimize it is really what it is. And what we have is considered, we're not going to quite go through it, but we have like an alpha level and a beta level. And like I said, they're hooked together. One gets bigger, the other gets smaller. The other gets bigger, the other one gets smaller. So that's a bit of a problem there. So hypothesis tests are often designed so the probability of a type 1 error will be acceptably small. I can't say that word right. Acceptable. So usually we go with 5% or 1% or somewhere in between. So like I said, because those type 1 errors are more serious, those are the ones we really try to keep down. So this value is going to be called your significance level. And what we also are going to call this is an alpha level. So we've talked about alphas before because we were looking at alphas when we were talking about confidence intervals. So alpha levels and significant levels are the same kind of levels that we were talking about when we were talking about confidence intervals. It's sort of like this, how much error can I accept into what I'm doing is what it really is. So we're looking for an acceptable amount of error. Okay, so example of errors. The dean of a business school wants to determine whether the mean starting salary of graduates of her school is greater than $50,000. She will perform a hypothesis test with the following null and alternative. So this is her claim. She claims that they're getting paid more than 50,000. So the null hypothesis is that, oh, well, then they're only getting paid 50,000. Technically it's 50,000 or less, but like I said, we're going with your book's way of doing a hypothesis test. So we want to decide if we have type 1 or type 2 errors. All right, so our situation is this. We know that the true mean is really 50,000. That is what is really happening, but the dean rejects it. So we have the null hypothesis is true, and we reject the null hypothesis. So when we reject a null hypothesis when it is true, that's your type 1 error. And if you need to, go back to that chart to look at it. I've actually got my chart here because admittedly, I have to sometimes look at that chart to think through my thought process. Except sometimes it just takes a little while to get that process in your head. The true mean in this case is going to be $55,000. And the dean rejects the null hypothesis. So null hypothesis is this, right? Null hypothesis saying that the mean, it should be 50,000. So null hypothesis is false if the mean is really 55,000. So null hypothesis is false. We reject null hat. We actually made the correct decision. And unfortunately, sometimes we never know if we made the correct decision or it's way down the line. We're just kind of hoping we do. Here, the mean is once again 55,000. So null hypothesis is false because it claims that it's 50,000 is the starting salary. And the dean does not reject. So they claim it. So null hypothesis is false. We keep or fail to reject. So if the null hypothesis is false, but we fail to reject it, that's our type 2 error. All right, go through this one more time. We want to decide if a type 1, type 2, or a correct decision is made in each case. So we have let's say maybe this is IQ. So we have a case where the null hypothesis is claiming the mean is 100. The alternate hypothesis is claiming the mean is anything but 100. The true value of the mean is 150. So null hypothesis is 100, but it's really 150. Null hypothesis is false. And the null hypothesis is rejected. So we rejected a false hypothesis. This is a correct decision. The next one is a test is made. We have a null hypothesis where the mean is 18. The alternative hypothesis is that the mean is greater than 18. The true value of the mean is 20. So the null hypothesis is false. And we do not reject the null hypothesis. So it's false, but we don't reject it. So when it is not rejected, so we fail to reject, but it's actually false, this is your type 2 error. So in this case, we have a test where the null hypothesis is the mean is 3. The alternative is that the mean is less than 3. The true value is 3, so null hypothesis is true. But the null hypothesis is rejected. So we rejected a true hypothesis. So null hypothesis is rejected, but null hypothesis is true. Type 2 error, type 1 error.